In the heart of Africa, a new energy revolution is rising.
At ZapTek, we are pioneering small modular reactors. Compact, safe, and sustainable. The machine learning interface is predicting a spike in efficiency.
It's incredible how much the city has grown.
We finally have reliable power everywhere.
From Ghana to the world, ZapTek leads Africa's leap into intelligent nuclear technology. ZapTek, or them, powering Africa's clean energy future.
Good afternoon to everyone. You're all welcome to this episode for the ZapTek Nuclear Research discussion. And for today's topic, we are going to discuss about AI integration in Africa's reactor management with members from our various nuclear technology team. So I'm in the person of Samuel Ajman, and I'm the research supervisor for ZapTek Ghana. Please, can you start introducing yourself?
Machine learning team.
Okay.
I'm Ernest from the chemistry.
Ernest, your full name, please.
I'm Ernest Recon from chemistry.
Okay. The last person.
Adusu Elvis, also from the AI machine learning team.
Okay. So today what you are going to look into is AI integration into Africa's reactor management. That is more focused on SMR development in Africa. Ghana is transitioning into a nuclear technology, and we are aiming to become a nuclear technology hub. So with this project and research, we are working on how we can integrate AI into facility management and also into safety systems that we have in the nuclear facilities that will be constructed in the country, and also other countries that will seek to develop this technology moving forward. That's our aim for this research projects. All right. Moving forward, we are going to answer few questions around this topic, and our guest here, that's our research team members, are going to give us answers based on their development and based on their knowledge in SMO technology. But before that, I would like them to talk about what they do in their respective teams. We have 4 teams: AI machine learning, that works on the AI model. We have the engineering team, we have chemistry team, and we have physics team. In our previous episodes, we have discussed some topics with the physics and the engineering team members. But today we have here members from the machine learning and also the chemistry team. All right. So Ms. Deborah from the machine learning AI team, please, anything from you on what you do in your team? What's your team contribution to the nuclear research projects I've been working on?
Okay, so with the data that we get from the engineering team, we create models that are used to train some of the data so that we can be able to test it on other data that will be given.
Okay. So have you worked on any models Are there any models that you have worked on?
Yes. So far, since I joined the team, I worked on a linear regression model to be able to predict K effective from enrichment percentage, which is the enrichment percentage is the percentage of uranium that is in the fuel, and then the K effective is how well the percentage of uranium can help us to get the energy that is needed for whatever purpose.
Okay, okay. And that's a great contribution to the team. Thank you. And your colleague, that is Elvis, also from the machine learning and AI team. Can you share your contribution with us?
Okay. So as my teammate Deborah said, we work with the models and then we work with the data set that we receive from the engineering team. So aside from the linear regression model, we also use the decision tree, which consists of many other models made up of it. So we also use the decision tree regression model to test on such data, such as the K effective and the enrichment levels. So that is our job. That is our machine learning job, using the various models to test the data sets given so that we find the most accurate model that predicts incoming data or the data that would be next given to us. So basically, I contribute by also testing out the various models, testing out other various models to find the accurate model to use. Thank you.
Oh, okay. Okay. So the engineering team have been providing you guys with the simulations. They work fully on simulated data. Then, so the data that you have been using are not real world data. They are simulated data on MATLAB based on the equations and development from the physics and chemistry team. All right. All right. Thanks for your contribution and submission on it. We have here our chemists, our only chemists. You came alone. Okay. So
Yeah.
how's your contribution on the nuclear technology research?
Okay. From what I know, our own is like mostly based on the theoretical aspect of it. And then my first contribution that I made with the other chemists are the types of the nuclear fission that focus on the SMR. So on that part, we made a slide. On my contribution, like we made some slides about them, talking about how they work, like the types of the SMRs that are available, like at that point. You get me?
Yeah.
Hello. So basically, like more types on the SMR, how they are used, and how they can help us in Ghana, like the profit and the benefit that we get in Ghana here if we use the SMR and all those stuff. So on my contribution, like
I'm going to start with Elvis. I'm going to start with Elvis. My first question for you is can AI replace human operators in reactors? Can AI replace human operators in reactors? As a AI machine learning expert working on this nuclear
A
technology.
very interesting question. Okay, in my view, there is some level to which AI can replace humans. but not fully. Because in my case, no matter how good we are at what we do, no matter how well we train the model, no matter how AI becomes more advanced, there's still that level of human touch, let me say that, that is needed, especially in regards to this sector or this field. We are talking about nuclear reactions and nuclear reactor. Such type of things, we don't leave them completely to these machines or these models or we've created. We can't entirely put our lives and those reactions upon AI. So, in my view, to some degree, can AI take over some part of human input,
Oh, okay.
but not totally? There's still a level of humans has to be with the AI in order to regulate some of these reactions.
Thanks for your submission. Um, Ernest, so as a chemistry expert, an expert in reactor chemistry, nuclear chemistry, do you think AI can replace humans operators in reactor management?
Per what the other guy said, saying say it cannot fully like replace it, but maybe somehow no. I think AI can basically replace it in a way, that per the question that you gave us the last time, no, AI can replace it in a way that there are so many technical things out there. We the humans, we can't do it on ourselves, like the corrosion and all those stuff. No, so there are things that we on like our normal eyes cannot see where and when or how like the corrosion, all those stuff might even come. So by using those machines and all those things, it can detect and even predict when and where like everything are going to be done and how to even solve it and how to even go about it. So we the humans, you can even say, although basically we are the one going to input the data and then get the information from them. So basically we are even depending on them to give us or even predict what's going to happen. So I'm saying is that let me say I'm sure is that like we are basically uh, depending on them, and then it can even replace it. It can even replace our human everything that we the humans we are doing, and the AI can replace it based on their how they are even functioning. That's what I think.
Oh, okay.
Because in it, you know, they are serving more purpose on what we are going to do, you know? And then they can even do and do it better, and then give us a better explanation on it per our views. You know, although as I was saying, that we are not going to input the data, but they are going to give us more details and then predict where and when and how everything are going to be done.
Okay. Thank you.
Okay.
Mr. Sam,
Yeah, Deborah.
please, can I give my input?
Yes, please.
So I think that in as much as we are using AI or machine learning intelligence to perform some of our tasks, it doesn't mean it can do the job perfectly. It can help make things more efficient and more faster, but then it can't do it on its own because nuclear reaction, we are dealing with a lot of dangerous stuff. Anything could happen. So if we are not able to train the model to that level of perfection, where if any new changes are made in the nuclear reactor, the machine learning model will be able to detect it. Then there's obviously going to be damages. There's going to be some damages. So we need humans to be there to be able to check out some of these things, these little errors that can be made. So I think that AI and then the human elements work hand in hand. So both must be present.
Okay. Okay. Thanks. Your submissions are always countering. Ernest. Ernest, today be whoa. They are from the AI and machine learning team, so they know the level of operation that the AI can.
Okay.
Yeah, so
I'm just saying my point of view, like what I know, that's what you should know.
yeah.
Because yeah, I know that like obviously we are basically depend on them because it's more efficient and it's very fast and it will help us. Like it's very easy. Although we are putting the data in and everything inside, but I feel like they are the one giving us, and then it can be trusted. As you were saying, said that one there maybe there can be some damages and there can be some damages, although but its efficiency is what you are looking at and then how effective it can be and how like it can help us, and that's what you are looking for. So if you say that it can damage and all, we are not looking at that part. We are talking about how it can even help us, and then what you are going to benefit from it. That's what I'm even talking about.
Oh, okay. Okay. I'm going to start with Deborah this time. You were talking about K effective and nuclear fuel, something. So how well can AI forecast power demand and help SMRs follow Africa's when you are given fluctuations in real time an enriched uranium, the how well can AI do that amount of power based on that can what you have worked on? Because you said you have worked based on the nuclear
Yeah.
fuel models that can predict um, how well can AI forecast this kind of power demand, the rate at and which help nuclear fuel SMRs can last follow Africa's grid fluctuations in power generation. Do you get my question? A certain
Um,
what
Not
how
really.
do you
Please, can you come
say
again?
this? A certain amount of nuclear fuel. How Ernest, I'm coming to you with a chemistry question.
Yes. Are we answering the same question as them or like our own?
Now you are going.
Okay.
I'm giving you a different question
Oh, someone
related
left.
related to chemistry. So, how could AI detect or
Hey,
predict?
I can't hear you well.
How could AI predict or
Hello.
predict corrosion? Ernest, can you hear me?
No, I didn't hear any of the question.
Can you hear me?
Yes.
Said, how could AI detect or predict corrosion early?
Uh, from the first question that came, I was saying something about corrosion and all those stuff.
Yeah.
Huh. So per AI, it runs through a whole lot of things, as in the mobile aspect and the satellite aspect and so many things. So in the machine aspect, we can use the AI to detect and even predict where and when and how like they are going to come, because with our naked eye, I'm not sure we can see those tiny particles that are on the ground that will make us detect that maybe at this place there will be some corrosion, or at this place there will be some erosion or some anything of that sort. So with the AI knowledge and how we input our data and all those stuff, so I think that we can determine them by using the AI.
So, how could
Not,
it
I'm not.
predict it early? How is it going to
Oh,
help
they,
in?
they have they have from the AI, they have let me say electrochemical stuff like that use that have sensors to determine them. No, so they have sensors.
And
Hello.
how yeah, you talk about the factors that causes corrosion and how AI is going to um, monitor these factors in order to help with early um, prediction
Hello.
or
Okay.
you
So
get
as I was
me?
saying that they use the electrochemical signals and so many things to detect them now. So we have this environmental factors and so many things that we can use to detect when and how and then how they are going to be used. So probably they have some tiny rust that are going to be shown there, but the naked eye cannot see the tiny rust that are going to be shown there. So we use those the computer to get some signals on them so they can see it. Probably that's usually using the computer aspect now.
Okay. I think for the detection, the throw detection, I think for that one we have to leave it to the AI machine learning members.
Now, I mean they use the computer vision. So the AI will use the AI together with the computer vision. That's when they use the signals, the
Okay.
electrochemical aspect into detect the tiny one. As I was saying, you can't use the naked eye to see the particles on it, to detect. So the AI will use the computer visions to detect. That one will even give us the early detection, so we can prevent it very fast.
Okay. Okay. I think we will need an extra layer from Elvis on how this detection is going to happen. Elvis, are you here with us?
Yes, please, I'm here with you.
Okay. So we are talking
You
about early corrosion prediction or assessments using AI. How
early.
does your how is your models, AI models that you are working on, going to help us with early corrosion detection?
Well, that would depend on our features, or well, we need certain amount of things for corrosion to take place. Let me say it like that. So corrosion, wait, are we talking about the elements themselves, or the what word should I use? The chemical elements themselves corroding?
So after talking about the chemical elements, then talk about how your models are going to check these chemical elements or detect these chemical elements to predict that corrosion is going to occur probably.
Okay, so the chemical elements, looking at um the field of nuclear energy, we are basically looking at uranium. That's like the biggest chemical element. So for uranium, it takes a while before some factors do happen. Like when you are creating energy from it, there's definitely going to be some form of corrosion or waste. So using that level of data from past history, we can be able to detect how gradual the rate of corrosion is. And as our boss said, using tools like sensors can really help in gathering that data for us to predict when or how fast corrosion is actually happening within these chemicals.
If you
Do
can
you
move
have any layer of explanation to show?
okay. I think that based on the data that is gotten from the sensors and electrochemical signals, we can classify the corrosion that is actually taking place. And we can also predict it using regression. So maybe for a particular part of the machine, we've gotten some levels of rust or something that helps us detect the corrosion. If we are able to measure these levels consecutively as time goes on, we can actually predict if we can predict how much it's going to be within a certain period, so we'll know how to control it and maybe which factors we must absent for the corrosion to be reduced, for the rate of corrosion to be reduced. That's what I think.
Okay. Ernest, Elvis, I'm not the one who is going to judge you. Ernest, are you there?
Yeah, yes, I'm here.
Yeah, I'm not the one who's going to judge. But feel free to share whatever you have. You get it. Feel free to share whatever you have.
Per what she was saying, I think we are more to go basically on the computer vision. And then
Yeah,
all we need is how the AI will detect the thing early, like the early detection, and then using the electrochemical and all those, to determine and even solve it. That's the thing, because the machine itself, no corrosion will even affect it, and then corrosion. Talking about rust and as you were saying, talking about rust and all those stuff, a lot of things can cause the thing to rust, even the environmental factors, and then how the machine will even stress can even cause it to even rust. But what we're even talking about right now is how the AI will detect it and then try to solve it.
yeah. So how could AI detect or predict corrosion early?
Predict it. How maybe the time it will take for it to rust or
Yeah. So the AI has to pick some detections based on computer
yeah,
vision. Yeah, and based on values from sensors. So
since it has sensors, maybe some to detect some
yeah,
micro things in them, so before
yeah.
it becomes visible for us to see it. I think
And
the AI.
then electrochemical analysis to contribute to these detections, because you can't use the other factors and leave the electrochemical aspect of it. Well, corrosion is more of chemistry, a chemical reaction.
Yeah, yes.
It seems I have a bit of chemistry left in me. I have
Yeah,
a bit of
yeah.
chemistry left in me. Deborah, how much of your chemistry is left after ACH? She's a Brilao. She was part of the NSMQ for a
Hey,
school.
Hey,
NSMQ.
no,
I can tell from how she's even answered the questions, so I can tell.
How we can answer these questions. So do you remember the model that you did with relate to the neutronics, neutron flux and fuel burnup? Deborah, Elvi,
Oh.
I want to ask you questions on the neutronics model, the neutron flux and the fuel burnup model. Can I move on? Is AI going to improve reactor safety? How is AI going to improve reactor safety? Deborah, ladies first.
how is AI going to improve reactor safety?
Yes, how is AI?
Okay, so with the nuclear reactor, um, one feature that it has that helps with the safety is the control rods. So the
Okay,
control rods are used to stop the nuclear chain reaction by absorbing excess electrons. So if we are able to create a model using AI to be able to move the control rods or the reactor rods according to how much fuel we want. It will help with the safety mechanism. And also to if we can have an automated shutdown so that where we realize that we are in the supercritical region, the whole system shuts down, and that would be good. But that will help with safety.
Okay. Okay. Ernest,
Yes, yes.
your submission on the topic, this safety, reactor safety. Before we end
Please,
everything, Ernest, your view on the topic, on the question, how is AI going to improve reactor safety? You know, you are a chemist, you know the chemical stuffs about nuclear reactors, the chemical reactivity of uranium.
Okay, so in that aspect, AI will improve the reactor's safety by uh, let me see, detecting the problem first, and then predicting like how we are going to solve it, and then give a clear decision. Say, oh, these are the things that we are going to need to solve this. So firstly, by detecting the problem, maybe in this uranium, this is going to happen, and then give us a clear details about what we need to do in order to solve it. As in, like it's helping us maybe a smart guardian to to help us do everything, to prevent all those accidents, and then it doesn't cause any mass effect, and then even try to extend the reactor's life. As in, say, it doesn't destroy the reactor. You get it? And then the AI to try to help extend everything. As in the control system, it tries to control everything.
Okay. Okay. Thanks. Thanks for your submission on the safety question. Elvis,
And
how
then
is it?
I'm saying something.
Okay. Okay. Okay.
So they can even set the AI to monitor how like everything is going on inside. So like it can even serve as like a monitoring condition. So it will monitor how things are going through there. So any glitch of mistake, the AI will detect, and then give us a decision on what to do, so we can prevent it and then extend the reactor's life. So
No.
accident or anything of that sort won't happen. So no one will get hit when maybe an accident causes for. Mhm.
Oh, okay. Okay. Thank you, Mr. Ernest. Okay. Elvis, anything from you on how AI is going to contribute to reactor safety? Hello, Elvis. We can't hear you. I think that you're muted yourself, but you can't hear. Okay. He has to rejoin. So there's this project that we are working on. It's a platform to learn about nuclear technology, um, rod behavior, control rod behavior. You can try simulations on the platform. So I wanted you to know when it's ready. Obvious.
Hello, can you guys hear me now?
Yeah, we can hear you.
Yeah, sorry about that. I don't know what happened.
Okay. So
Mhm.
talking about how AI could help or is going to contribute to reactor safety. How is AI going to contribute to reactor safety?
um, yeah, so AI is actually going to contribute a lot in reactor safety in terms of the elements being used and then as well as the equipment being used. Everything has a lifespan. Everything has an amount of time that it can be used. So I hope I was being
Yeah, we
heard
can hear you.
clear. Okay. All right. So I was saying that something like the equipment that we use to monitor nuclear reactions to AI can predict how long we can use them or the lifespan of their use before they are changed or before they are replaced. Because if you don't replace them, those tiny factors can cause problems in nuclear reactors. So yeah, AI can predict how long the chemical elements can be used or are stable for power production and how long equipment too can be used so that they can be replaced in order to prevent any other problems that might arise from faulty equipment. Thank you.
Okay. Okay. Think that's great submission from everyone so far. Yeah, that's great submission. We are talking about AI, so anything AI, I think based on your submissions, you are doing good in your various teams. Deborah, are you here with us?
Yes.
Okay. Our last question is going to be a general question based on your view. Deborah, so machine learning and AI experts working in this nuclear technology research. What are the problems that you are facing and what are the things that you need from external partners in order to perfect your development?
If please, can I think about it for a while?
Yeah, yeah. That means the only problem there. Oh. Deborah,
Yes.
there's a only problem there. Oh, on how you are working. Like you don't need
No,
anything.
as of now, we have most of the stuff from like computer applications. Everything is available. Almost everything is available online. So for AI and machine learning, all you need is data, models, and then I think you understand it.
Okay. So you have problem. You have a problem. Your problem is based on the.
Okay.
Mhm. So Deborah, what are the problems that you face as a machine learning expert working on this nuclear technology project or research? And also, okay.
He said,
I'm going to repeat the question.
okay.
So as a machine learning and AI expert, what are some of the problems that you face when working on models for this nuclear technology projects? Deborah,
Okay, so right now we are using simulated data to train our models, and it will be best if we get actual data or real data from some of the nuclear companies, so that our models can be more accurate and we'll be able to use them in real life.
Okay, that's a great submission. Thank you, Miss Deborah. Elvis, do you have any add-ons? Okay.
So another problem I would say is that the normal problem most machine learners have, that's with overfitting and underfitting. Just trying to make, with the data that we have access simulated, we're just trying to make like try to use the best model to get, I would say, the most realistic and most accurate predictions yet. And so problems of overfitting, making the model try to fit every type of data, or every type of data set given, and then the problems of underfitting are what is mainly our problems, aside from the data set that's given.
Okay. Okay. Ernest, do you have any problem? Always thanks for your submission. Okay, so do you have any problem with regards to the things that you are delivering? Do you need any lab involvement in it to make sure that you submit the right feedback to the engineering team to be used for data set preparation? Do you have any problem with relate to that? Not about your teammates, but based on what you are delivering, will you need any lab validation before submitting
Yes,
it?
yes, yes, yes. And even as Deborah was saying about how they need real life, what is it, values or uh,
Ye- Data
data,
set.
data, data to, I mean, to get to understand and do everything in real life. You know, we also need the lab aspect, and then we've been doing the SMR and everything, but we've not seen it, and we don't know about most of them. We're just learning the theoretical aspect and giving details about the theoretical aspect. So I think, for my view, we would like to see it and then get a hand-to-hand touch on it and see how things really work on it.
Okay, so you would want to have an actual feel of uranium and
Yes, yes, yes.
work with it at the lab, right?
Yes, please. Yes, please. We've heard about it a long time ago, so we want to know uh, how it looks like. What can we possibly be doing with it in hand to hand, not in the theoretical aspects. No.
Okay, okay. Thank you very much for your submission, Mr. Ernest. So that's all for today. That's all for today. Yeah, but I think there are still room for improvements moving forward. As I said, we have one large discussion that we need to get it done, and also make sure that we finish up with the models as soon as possible. Okay, so for today, thanks for your submissions, Deborah, Ernest, and Elvis. Yeah,
Okay.
your contributions to the tax have been paying off, and there's more room for improvements. You are still learning, so I think moving forward, things are going to get better. But you have done well. You have done pretty well. All right. I'm going to see you in the next episode. There are going to be new faces in that episode, but see you in the next episode.
Okay, thank you very much.